Hello everyone, welcome to a new series. My name is Dr. Hemant Ali Shah. Welcome to the world of image processing, computer vision, deep learning. In this series of videos, we will cover the basics of the YOLO model and theoretical and practical aspects. We compare the performances of YOLO 11 and YOLO 8 using publicly available data set using wood surface fault detection. We will find faults on wood surface and test these models YOLO 11 and YOLO 8. Please keep watching both the videos. This session covers automated fault detection in wooden surface of doors and windows. The presentation highlights the application of YOLO, groundbreaking computer vision algorithm to identify faults like nodes, cracks, and other imperfections with precision. Let's explore how this innovation, manufacture, and quality control in the wood industry works. Keep watching. Okay, let's begin with the introduction of YOLO. YOLO, or You Only Look Once, is a deep learning approach for object detection. It is designed to identify and locate objects such as cracks and nodes, and there are other wood surfaces issues in real time. Unlike traditional two-stage method that are slower, YOLO operates in a single step, making it faster and ideal for applications like quality control. YOLO V1 marked a milestone in object detection when it was introduced in 2015. It offers significant improvements over traditional method, including faster processing, high accuracy, and adaptability for a wide range of applications from self-driving cars to medical imaging. Here we can see comparison of YOLO 7 and YOLO 8 in the image and on wooden surface detecting faults with remarkable accuracy. Training a YOLO model involves several steps. First step, we prepare the data by cleaning, annotating, and splitting into training, validation, and testing sets. This is like data preparation. Next, we select YOLO model selection, architecture based on the speed, accuracy, and requirements. Then we train, third number, train the model iteratively and evaluate its performances. Finally, the fine-tuned model here is developed for real-time fault detection. We start by collecting the dataset online. We collect one dataset that focuses especially on identifying nodes. Nodes are type of the fault in wooden surfaces. In the dataset, each image is labeled with the bounding boxes to highlight the location of the node, which ensures precise training for the YOLO model. A platform like Roboflow helps manage and annotate these data sets. So we download the data set from the Roboflow website. Our data set consists of 2,924 images split into training, validation, and testing sets. There are three sets: training, validation, and testing. So for the quality, we ensure the training process goes smoothly and efficiently. In this slide, I just try to show you how our data sets looks like. These are raw images taken from the wooden surfaces where we just try to train the model these images, and then after training the model we test on different set of images our model. So Images in the data are then labeled with the bounding boxes while we are doing the training process to indicate node location. And this step is critical for effective training and fault detection. The dataset quality directly impact on the model performances. Okay, now let's compare YOLO 8 and YOLO 11. To evaluate our models, we use precision recall and MAP, mean average precision. So we compare and using speed, precision recall, and MAP evolution matrices. So YOLO 8 is slightly faster and has better precision and MAP 0.5, while YOLO 11 has a slightly higher recall. Both model performs equally in stricter MAP evaluation, demonstrated their robust performance for the different applications. So YOLO 8 outperforms YOLO 11 in two of the things. So I will recommend please use still YOLO 8 in your application when you are dealing with the wooden subjects. And now let's conclude the presentation. In conclusion, this automatic fault detection system, YOLO, is a game changer for the manufacturing of doors and windows. It significantly enhances quality control, improves efficiency, and reduces costs, making it a valuable addition to modern production pipeline. So in the next video, I will teach you how to implement and test both of these models, YOLO 10, YOLO 8 and YOLO 11. And we will download the data set and I will show you how the process goes. Thank you for watching.